Okay, so in this video I want to learn how to draw 3D shapes with Raylib. I'm saying this as I'm stretching. That feels good. Okay, so I already did a few of the examples here. Just tried to do them myself and while making sure that I was really understanding what I was doing. So now, so that was for 2D. Now I'm going to do 3D because my end goal is to just create a rather simple 3D game. I don't know if I'm going to end up using Raylib or not, but yeah, I mean, that's what I want to do. So 3D camera mode, let's look at this example. So I cannot move or anything, right? Welcome to the third dimension, and here we have some of the code. So let's just look at the way the code is structured here. So we have, so include Raylib as usual, and then, well, what changes from the other examples in 2D? So we have a 2D camera, 3D camera instead of 2D, and the position is going to be a 3-dimensional vector. Target as well. Up means camera up vector, rotation towards target. I'm not sure what that means. I will look it up afterwards. Camera field of view Y. Okay. Camera projection equal camera perspective. Okay. Vector cube position will be this, so 3-dimensional as well. Set target FPS 60 and begin drawing, clear background, begin mode 3D, draw cube wires. So wires, what are cube wires? So I'm guessing the edges. Draw grid, so 10, 1, 2, 3, 4, 5, 10, okay. I'm not sure what that is. End mode 3D, draw text, draw FPS. Oh, so you can just do draw FPS instead of okay. Instead of having to do draw text and all that. Okay, and drawing close window. Okay, so let's do the beginning without looking at the code. Just set up the basics of the file. So new item. Let's make it a C++ file and let's call it something like 3D camera. Okay. Let's see. Oop, I'm just going to reply to a friend. Okay, so let's include, oops, I didn't mean to do that. So let's just include Raylib, right? And so the first thing we're going to do is do int main and let's see. So what is the logic? So we're gonna have two const integers, so screen width equal to, in my case, let's do 1280, and const int screen height equal to 720. And then let's do, so what it was, it's init window, screen width, screen height, and the title should be, let's make it first 3D camera project. Okay. What else should I do? I'm not sure. Is there anything else I should do? I'm trying to do it out of memory, but otherwise I'm just going to look at the right side of the screen. Okay. I'm not sure. Okay, so in window, oh, initialize the camera. Okay, I just looked at the screen. So camera 3D, camera, let's make it equal to, let's put everything to 0 at first. Let's just see how this is defined. So camera 3D has a position target up. So camera up vector rotation over its axis. Okay. Target, camera target it looks at. Okay. Field of view. Okay. Field of view aperture in Y degrees in perspective. Used as neoplane width in orthographic. Okay. Camera projection, camera perspective, or camera orthographic. So I think I'm going to do perspective here. But let's see. So camera position. Should we make it just 0 everywhere? No, because if I make it 0, then it's going to look inside the cube, and that's not necessarily what I want. So I guess I have to make it. I'm not sure. I'm not sure how it works. Let's see. Let's look here. Camera position. Right. So 0 in terms of x, y, and z. I'm guessing. So 0. So the x-axis is this line. Y is going to be the height. So we're above and a little bit behind. I see. So that's why we are here. And we are targeting 0. So we are targeting the middle point here, the center of the cube. Or not necessarily the center, but the center of the grid, like the origin of this three-dimensional dimension. 3D dimension. So it's kind of a repetition here. A pléonasme, as we say in French. So then up, camera up vector, rotation towards target. Okay. Field of view Y, 45. Okay. And okay. So let's see. So what we want to do here is do camera position. And so it's supposed to be a vector 3. And can I make it so 0, right? What else? So I think it was, yeah, it was 10, 10, 10. Let's see if I can do that. Does that work? Yes, I have to remove that. Then there was camera target. So let's make the target 0 as well. So 0, 0. Let's just make it explicit, because I'm guessing that by here initializing it with 0, it puts 0 everywhere. So I probably shouldn't have to do this, but just to make it more easily readable, let's just specify it here. It's just a simple instruction anyway, so it's not like it's wasting a lot of power, a lot of memory as well. So camera field of view Y used as neoplane within. I feel like I don't necessarily need this, so I'm not going to put it projection. So let's make it camera perspective. I think that's what it's called. What is a real value of that? That's 0. Okay. And let's see. So we have up, camera up, vector rotation over its axis. I'm not sure. And target. Okay, so let's just leave it at that for now and see what we get afterwards. So we have that. Now I should probably create my cube. So how can I do this? So can I do cube? Do we have that? Draw cube V. What is that? Vector. Right, and otherwise, what do we have? Position, width, height, length. So I guess I'll just have 2 vectors. So vector 3, let's make it a cube position, and let's just put it at the center, right? I wonder if that is going to be the center of the cube. Probably it is, yes, because usually a rectangle, the center is going to be on the top left. But for the cube, I'm guessing that since it's 3D, maybe it's going to be the center of gravity. I'm not sure. We'll see. Like what point in the cube does this do a reference to? Like what does this reference? 0, 0, 0. We'll see. So vector 3 cube cube. So since it's a cube, just want it to be a cube. Let's make it size, and let's just do it 10 everywhere. Okay. Is there anything else? Right, so maybe I can make it color, cube color equal to I think I can do get color and hex value. So hex value is going to be 0x something. So let's make it what should I do it? Let's just make it white, or whatever this is going to give us. Let's just try doing this. So get color gives us a color. Okay, fair enough. Now set target FPS, and let's make it 144. Because why not? And so while window should close, we're not going to handle inputs in this example, so I guess I can just do begin drawing, end drawing, and here I guess I can do begin mode 3D, given the camera here, and end mode 3D. And so here we're going to do a draw cube. What's this? So what is draw cube wires? I'm not sure what that is. Let's just check the definition. Draw cube wires. Well, thank you very much for telling me what that is, but it doesn't really help. So if I look at it here, draw cube wires, cube position, maroon. I feel like, yeah, I mean, it's probably just the edges. So let's just do here draw cube V and cube position, cube size, and cube color. Right, seems pretty explicit. And here let's just do draw FPS, and I guess let's just make it 1010. And yeah, I mean, I wonder if this is going to compile and run. I guess I should add here close window, and then at the end return 0, since we are in the main function after all. But I feel like other than that, this is pretty straightforward. Should work. Right. So maybe here I should do begin drawing, something like clear background, and make it ray white. Does this change anything or not? Right, so that does change something, but now we cannot see our cube. So maybe it has something to do with the camera. So if I just copy what we have here, so position target, then so camera up equal to 0, 1, 0, and if I do here camera field of view Y equal to 45. Okay. Is there anything else I'm missing? I don't think so. So if I run this, what do I get? Ooh, okay. Okay, let's see. This cube is a little bit big. That's for sure. Let's see. I think they drew a plane here, or grid, I mean. So let's do it as well. So let's do draw grid into slices. So let's do same 10 and spacing So I guess I can just do 1 here. Let's see what this gives us. Right, I'm not sure what I'm not sure I know what I'm looking at. So maybe if I draw the wires, maybe I can do this. And here, cube position, cube size, and let's make it red, since we got a yellow color. It should stand out. Okay, so this is what I'm looking at, but I guess I should just make it a little bit smaller, right? If I make the cube 3, 3, 3, it should make it smaller. And yeah, okay, so that looks pretty cool. So if I want to make it perfect, I should make it 2 in order to make it just exactly the size of 2 squares, like here on the grid. 2 squares. All right, cool. So that is doing a pretty good job. Now, let's see. Is there anything else I would like to do? So if I do cube size, can I do 2 times? Does it understand it or not? No, it doesn't. Maybe like the operator. I thought maybe the operator had been overloaded, but okay, so let's just do vector 3 cube wires size, make it this way, and let's make it here 2 times cube size of x, 2 times cube size dot y, and 2 times cube size dot z. Okay, and let's just call it here, and here I can do and here I can do color cube wires color, and do a get color. Let's make it red. So red should be RGB alpha. So let's see if this gives us red or not. Let's see. This does give us red, and it does make it bigger. So that's interesting. And so now what happens if now let's see. So we basically have something like that. So same as in the example. Now let's see what I can do with that. How can I do stuff? So if I remove this, what does it do? Field of view equal to 0, right? Right, so the field of view is important. That's fair enough. Makes sense. So if I make it, I don't know, like 90, it's going to make it this way. Okay, just like it's the same principle as in Minecraft. If I make it smaller, it's just going to make everything just more zoomed, or not zoomed, but yeah, appear closer, I guess, or bigger. But I think I understand it. So 45 was good. Now if I remove camera up, what does it do? Camera up. So if I don't have this, it really doesn't go well. Camera up vector rotation over its axis. Okay, let's see. So Raylib camera 3D up attribute. Oops. Okay, Raylib camera. Okay, Raylib, what is I don't mean to do that. What is camera 3D up attribute? Camera up. Okay. Now, hi, first, does anyone know what camera up is? Okay. And that is the direction that is up for the camera. If you give it 0, 1, 0, then Y is up. If you gave it 1, 0, 0, then X would be up. An object in front of the camera moving back and forth along the X-axis would appear to be moving up and down the camera. Oh. I think I get it. So it's like, it allows us to... So it allows us to tell us which one of the 3 axes will be the one that represents the one going up. So, okay, so if I run this, the fact that I put 0, 1, 0 means that the y-axis, so that goes from top to bottom, is the one that represents going up. Okay, I get it. I think I get it. Cool. Cool. So let's do something, a little bit funny. So let's do while camera dot field of view is above or equal to 10. Let's just do camera dot field of view minus equal 1. Let's just make it this way. Let's just see what it does. Ooh, so it changes it really quickly. So let's just make it this way. Oh, it changes it really quickly. Oh yeah, right. No, it's because I did a while loop here. I should just make it if. Okay, that's some quality animation right here. Okay, so that's how it works. And now let's do now let's just do if camera field of view y is equal to 10. Let's just reset it to something like equal to let's just make it 90. Right, see what this does. It's going to zoom, then reset to 90 and then go back down. Oh, so I guess I should do this. No. I guess below or equal. Going to give a better range. Right, and now it works. So this is just going to do it in an infinite loop. Right. Right, so that allows me to visualize how this works. Okay, cool. Now, can I do a smooth animation instead of making it teleport? So, I guess I can do something like int f of y direction, and first it's going to be -1, and then let's just do if camera is above or equal to, no, let's just do camera direction. Let's just do direction. No, it's not how I should do it. So let's see. Right. Right, so I guess I should just do camera field of view y. Plus equal 0.1 F times that is the direction. And here let's just do if camera, let's just do camera this is below or equal to 10. Then what we're going to do is just change the direction of this. So we're just going to multiply it by -1, and then there's the opposite here at 90, below or equal 90. Then the direction is going to change as well. So times -1. Oops, I'll make it 90 here. So I could just make it one line. Actually, let's just make it one line. Or now let's see if this works. Is it going to bounce? Ooh, it is going to bounce. Huh. Alright, let's just keep it this way. I think it's pretty funny. So 10 to 90. Okay, why not? Let's keep it this way. Now. Camera position. So I mean, camera position at first it's this, right? So if I want to make it turn, I have to make it follow the path of a circle, right? I'm a bit too lazy for that. I think I know how I would have to do it. Like I would have to do some trigonometry or whatever. There's probably an easier way to do it with Raylib. But I feel like this would be needlessly complex for what I'm trying to achieve here. So let's just do something like wait, actually, let's do something like let's do int cube x direction equal, so at first it's going to be -1 as well, and here we're just going to do cube position dot x plus equal, and let's make it I guess I can make it 0.1 and see how it goes, times cube x direction. And so here we'll do if cube position dot x is below or equal to, let's see, -5, or cube position dot x is greater or equal to 5, then we're going to do cube x direction times equal -1, right? This makes sense to me. Right, so it's moving pretty quickly, but it is doing what I was expecting it to do, so that's pretty cool. So doing some animations in Raylib is pretty easy. Now, how can I rotate? So let's make it actually, let's just make it a little bit slower. Right. So we are at 144 FPS. In reality, what I should do is something like, so I know this exists. I can do int dt will be equal to get, I think it's frame time. Yep. And so this, and then I should multiply everything by dt. Or actually, maybe I'm just going to do it times dt here. Let's just do it, and it's probably going to make everything slower, right? Yeah. Is it moving at all? Kind of looks like it's not moving at all. Now, if I make this 100, and I make this like 50, Let's see if this anything. No. Int dt equal get frame time. I'm not sure, honestly. No, I would have noticed something if it really did something. I guess I should just, so if I do here, include IO stream, and here I do the print out DT, let's just see what it does, what it says. What is the value of DT when I do that? Right, so DT is 0 because, so this should be a float. Okay, fair enough, that's how you debug stuff. And I think now it's going to move. Oh, okay. Okay, boy. Okay. Okay. Okay, calm down. So let's just make this 1, and I guess 0.5. Let's see what happens now. Okay. And now let's make it 10 times faster. So 5. Okay, so now this works. Okay, cool. Now, what I really would like to know is how to rotate stuff. Because I have the position, I have the size. Let's look at what a cube can do. How can I rotate something? Position. It doesn't have to do with the position nor the size. So it has to be something with a rotation axis. But I don't have that for cubes. Okay. Let's see. So Raylib rotate cube. How do I rotate a cube? For the love of all that is holy, I like to just rotate a cube as well. So I have to do transform. Right, so test cube here becomes a load model. So let's see what happens here. So transform vertex transformation data. Transform. Okay. Cube rotate. What do I have? Image rotate. I guess I can't really rotate a cube here because I don't have it as an object. Even if I do like cube position, right? So model. Model meshes materials and animation data. Okay, so to me it looks like I cannot make a rotation on a simple cube that I drew using this. If I want to do that, I have to use another way of drawing a cube. Right. So let's see, position. Let's change the position of the camera. Let's change the position of the camera. Let's make it go up and down. And the target is going to remain 0, so since the target is going to remain 0, maybe it's going to rotate along the okay, like spherical coordinates. So let's see, int camera y direction equal -1 at first, And here we're just going to do camera position y plus equal, let's just make it 0. Let's just make it so camera was at 10 at first. Let's make it 2.f times camera y direction times dt. And here let's just do if camera position y is below or equal to -10, or camera position y is greater or equal to 10, then we're going to do camera y direction times equal -1. Why not? Let's just do that. Ooh. Right. Alright, that's pretty cool. That is working. Okay. Now let's make it a little bit faster. So 5 here, and let's just comment this out. See what happens here. Right, so it is working. It's working pretty well. So the target remains at 0, so it's rotating along, I guess, not spherical coordinates. No, it's not for me, it's not circular, a circular trajectory, it's just moving up and down and nothing else. If I wanted to make a spherical movement, circular movement in space, I would have to change not the x-axis, but the z-axis, z value of the position. But this is working pretty well. So, okay, I'm just going to stop this here. And in the next video, I'll just try to go a little bit further, dig a little bit deeper in how cameras and objects work in 3D in Raylib. I'll try to make it so that I can move freely in the application. I can move the camera freely with my mouse. I'll try to see how I can make a cube rotate. And yeah, I mean, maybe I'll also use keyboard inputs to be able to do some stuff. So yeah, thank you for watching, and see you in the next video. Goodbye.